Assalamu alaikum warahmatullah. Today we'll be discussing multi-carrier systems, which is a very important technology used in wireless communication and also in wired communication as well. So we'll be talking about it in an introduction, discuss the basic principles of multi-carrier systems, and then move on to multi-carrier modulation, then talk about subcarrier fading mitigation, which is the most important feature of the multi-carrier systems. Then we will talk about again multi-carrier implementation, and we will end the discussion here. So as a motivation for multi-carrier systems, when we have a high data rate system, okay, the limiting factor is the delay dispersion, which is causes intersymbol interference, and this also causes wideband fading, right? Wideband fading. So since the symbol period becomes smaller when we increase the data rate or the bandwidth, the channel delay becomes more pronounced. So we can feel it. It will have more effect on the received signal. So like we said earlier a bit, ISI causes wideband fading, which is also known as frequency selective fading, and a traditional way to mitigate or to deal with such fading is use equalization. But for high data rates, the channel impulse response becomes relatively long, meaning that the equalizer will become very complex. So to deal with that, meaning to avoid having very complex or very long equalizers, the way to do it is to divide and conquer. So we divide the bandwidth into n subcarriers with smaller bandwidths. Of course, the new subcarrier band will be b over n. So in this case, the wideband or frequency selective fading will be converted to a flat fading. So if you have like this channel, right? So as you can see, uh, the, the frequency response changes with the frequency. If we divide it into smaller bandwidth or subcarriers, each subcarrier will be treated individually, and as a result, the equalizer needed for this subcarrier will be shorter and hence simpler, right? So how do we convert flat fading, frequency selective fading to flat fading? Of course, we need the subcarrier bandwidth to be smaller, much smaller than the coherence bandwidth, okay, which is approximately is a multiple of the inverse of the delay spread. For example, in the GSM systems, the equalizer has 20 taps, okay, and in GSM we have a bandwidth of 200 kilohertz with comparison to 3G, which is around 5 megahertz, and you can say in 4G it's around 10 megabit per second or maybe more. So I mean, multi-carrier systems, they are not a new technology. They appeared in the late 50s and early 60s, okay, as a military application for high frequency radios for communication, and then it became a civilian technology in 1966. In the 1990s, multi-carrier systems were used in wired communication, especially in digital subscriber lines DSL systems that provided at that time high data rate. Okay. Also, it was used in digital audio broadcasting and digital video broadcasting, right? And it's used in Wi-Fi generations. So you have new the early generation A, and you have it in the G generation. Of course, now you have D and E and F and so on. Okay, it was also used in WiMAX and of course in LTE 4G systems.